Hi, my name is Michael, and I'm against the topic that increasing financial commitment to hydrogen technology, so increase funding. I'm going to be going over the workability and disadvantages of this proposition. And the things I'm going to want to claim first is there's already money in for hydrogen technology, as our opponents actually said, that there's a $1.2 billion initiative, and that if this is a viable source of renewable energy, then it should change over time, and the money we have in it should work with the present system. Also, I'm going to want to claim that hydrogen is not a practical way to store energy, as my partner started to say, and that hydrogen is very costly and very wasteful. So first, there's already plenty of funding. As they stated, in 2003, President Bush declared it was time to take a crucial step towards protecting our environment. He announced that $1.2 billion initiative to begin developing national hydrogen infrastructure. And then also by a fuel expert named Ulf Bussel, says there's a lot of money in the field now. I think it was a mistake to start with the President Initiative, rather than with a thorough analysis like this one. Huge sums of money were committed too soon. So basically they want to take away money that we're getting for that people are getting for fossil fuels without any with just research. So we'd lose money towards, gas prices would go up for something that we can't even, they haven't even given us a time frame of when it would start, whether it be decades or before, after our time. The next thing I want to point out is hydrogen is not a practical way to store energy. This is from psych.org.com, and it would take about 4 renewable power plants to have to deliver the output of 1 plant of stationary or mobile consumers. So basically, you need 4 plants. As my partner showed, that it takes energy to get hydrogen out of a liquid or whatever, and you need 4 just to get energy profit, if to put it in a certain way. And what Ulf Bussel says is there's a 1/4 efficiency, as I was saying, and it's based on necessary process of hydrogen economy and the properties of hydrogen itself. So you can put as much money as you want into it, it's still not going to work. It's hydrogen. It's not going to change with more technology. There's 3, hydrogen is difficult to store because it has very low volumetric energy. As they said, it has like 3 times as much energy as gasoline, but it must be made more dense to be used for transportation, like cars and planes and stuff. And there's 3 ways to do this: compressed and liquefied, and also chemically combined. To compress it, it would have to be compressed to 800 atmospheres. And that it would occupy 3 times as much volume than gasoline for the same energy. So that works out to about 12,000 pounds per square inch. That's really, really pressurized. If you can think your car tire is like 33 pounds per square inch. And it's very difficult to contain such pressure safely. Catastrophic tank failure would equal as much energy as a dynamite, as an equal weight in dynamite. So even if it was a pound of hydrogen in your car, that could still easily kill you and anyone in the car and possibly cars around you. And this is all for planetforlife.com. A truck would also, to do this safely, it would have to have a steel tank, which would be in practice weigh nearly as much as the vehicle. So now the tank, as my partner described, would be 4 times the size and also would weigh the same as the truck. So now you need even more energy just to push the same vehicle. And this is from popularmechanics.com. Currently, most hydrogen is transported in by tankers, as my opponent said, or gas cylinders by trailers. Trucking compressed hydrogen 150 miles burns diesel equivalent to 11% of the energy in the truck. So just to move it across burns 11% of energy, so we're using fossil fuels there. And the same 44-ton vehicle that can carry enough gasoline for 800 cars would only carry enough gasoline to fuel 80 vehicles. So now you have to do the trip 10 times just to equal the same amount of cars, so now you have 110% of fuel burning just in moving it. I want to start claiming that the use of hydrogen is very costly and very wasteful. And when I say wasteful and costly, I don't just mean in money, it's also costly and wasteful in energy. It's costly to convert to liquid because hydrogen is gas and it cannot be compressed into a liquid without intensive cost and energy input. So now we're using energy to make energy, as my partner was explaining earlier. One way you could avoid this would be pipelines. And right now there's about 700 miles of hydrogen pipelines in the United States, and this is also from Popular Mechanics. And we need about 3 times as much for for a hydrogen economy, or to move away from fossil fuels. And it's about $1 million per mile just to treat the pipelines. It's maintenance or any like the fact that they're high pressure. It takes a lot of work. That's $1 million a mile just on that. That doesn't have to do anything with building them, or if there is explosions or problems. So there's tons of money already into it, and it's also wasteful of energy. Another way to do it, as I was explaining, was to combine with other things, like certain alkaline metals can release hydrogen when exposed to water, but however 70% of the energy is lost just from that. And basically, it's, as I was saying, there's already money into it, and if there was any possible way hydrogen could be technologically advanced to work for our society, it would happen over time. It's not practical, and they want to take away our money. They charge us more for gasoline, and we still can't even use the hydrogen technology. We can only hope that maybe our children will have hydrogen technology, which, as I showed, is also impractical and probably not even feasible.